Hi, what is the value of k? Given that you have k to the power of 6 equals open bracket k minus 5 close the bracket to the power of 6. Then let's have it to be solution. From here, let's take this to the other side. Then we have k to the power of 6 minus open bracket k minus 5 close the bracket to the power of 6. Then we set everything to be equal 0. Then we can re-express this as k to the power of 3 all in bracket to the power of 2, because 3 times 2 will give us 6 minus k minus 5 all in bracket, then okay, open to the power of 3, then again to the power of 2. Then we set everything to be equal 0. 3 times 2 will give us 6. Then we are looking at this expression. This one has power 2, this one has power 2. This is difference of 2 squared. That says when you have a to the power of 2 minus b to the power of 2 equals as open bracket a plus b, close the bracket, multiply by again, open bracket a minus b. So simply applying it here, we are going to have k to the power of 3 plus open bracket k minus 5 to the power of 3 as this. Then again multiply by k to the power of 3 minus open bracket k minus 5 to the power of 3. Then we close it. So we set everything to be equal 0. Then what are we trying to say here is that for this particular expression to be equal 0, is either we have k to the power of 3 plus open bracket k minus 5 to the power of 3 equals 0. We can say this is case 1, or we have k to the power of 3 minus open bracket k minus 5 close the bracket, then to the power of 3 equals 0. We can name this as case 2. Then let's solve the case 1 first. From here we are going to have k to the power of 3 plus open bracket k minus 5 close the bracket, then to the power of 3, everything equals 0. Remember, when you have a to the power of 3 plus b to the power of 3, this equals as when you have a plus b again multiplied by a square minus ab plus b square. So when you apply it here, our a is k, our b is k minus 5 all in bracket. So this will be k plus open bracket k minus 5 as this, then again multiply by k square minus a is k, b will be k minus 5, then plus k minus 5 all in bracket to the power of 2. We close it, then we set everything to be equal 0. So from here we have open the bracket with this one will be 2k, then minus 5, close the bracket, open another bracket, multiply by k square. This times this will be minus k square. This times this will be plus 5k. Then when you open this bracket, what we are going to have will be plus k square minus 10k plus 25. We close it, then we set everything to be equal 0 when you open this expansion. So from here we have 2k minus 5 open bracket. It is believed that this and this will cancel. We only have k square here. We have 5k minus 10k will be minus 5k plus 25. Then we set everything to be equal 0. From here, it is true that for this expression to be equal 0, either we have 2k minus 5 equals 0, or we have k squared minus 5k plus 25 to be equal 0. Then from here we are going to have 2k to be equals 5, dividing through by 2. This and this will cancel, so we are going to have k to be equals 5 divided by 2 as the first real solution. Then from here we can get the positive value of k by introducing quadratic formula, as k will be equals minus b, positive or negative, square root of b squared minus 4ac, all divided by 2a. Then where we have our a, coefficient of k squared will be 1. Then our b, coefficient of k, which is minus 5. Then our c will be equals 25. Then when you substitute everything here, we have k to be equals, minus is outside already, we have here to be 5, positive or negative, minus 5 all in bracket to the power of 2 minus 4 multiplied by, our a is 1, then our c is 25, then all divided by 2 into a is 1. Then from here we have k to be equals 5, positive or negative, roots of 25. This times this will be minus 100 divided by 2. K will be equals 5, positive or negative. We have here to be minus 75 divided by 2. So we have k to be equals 5, positive or negative. We can simplify 75 as 25 multiplied by 3 multiplied by minus 1, then divided by 2. We have k to be equals, now 5, positive or negative. Square root of 25 will be 5. We have root of 3, it's not perfect. Root of minus 1 will be I, then divided by 2. This is another solution, and this is a complex solution. Why we have a real solution to be k equals 5 divided by 2. Then let us recall from case 2. From case 2, where we have k to the power of 3 minus, open bracket, k minus 5, close the bracket, then to the power of 3, then we have to set everything to be equals 0. Then when you apply this, when you have a to the power of 3 minus b to the power of 3, always equals, as when you have a minus b, all in bracket, again multiplied by a squared plus ab plus b squared. Then applying it here, we are going to have k minus, open bracket, k minus 5 as this, again multiplied by k squared plus a is k, b, k minus 5 plus k minus 5 all in bracket to the power of 2. We close it again, we set everything to be equals 0. So from here, when we open this bracket, we are going to have k minus k plus 5 as this. Here will be k squared plus k squared minus 5k. Open this one, you have k squared minus 10k plus 25. We close it, we set everything to be equal 0. So this and this we cancel, we have 5 outside. Here will be k squared is k squared. We have it to be 3k squared. Then here will be minus 5k minus 10k. We have here to be minus 15k plus 25. So from here, divide through by 5. This will cancel. We have 3k squared minus 15k plus 25 equals 0. So solving this one quadratically, we are going to have k to be equals 15, positive or negative, 5 roots 3i divided by 6. So therefore, this is another solution. If you are new here and you find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more math tutorial videos.